All right, today we're going to do Unit 4, Lesson 5, and this still is in our exponential functions units. So I wanted to go ahead and start out by sharing with you the formula that you're most likely to see. And that is at the top of my paper where I see y equals a parentheses 1, and then here's what this is. On the top, this is a plus sign, and then on the bottom is a minus sign. What that means is that there are two options for this equation. You can do 1 plus r, or you can do 1 minus r. Well, for our lesson today, I have separated these for us. So the plus is going to be when we have something that is growing, and the minus is going to be when we have a situation that is decaying. Okay, so this is exponential growth and decay, but I broke them down. So it kind of looks like two equations in our notes, but just keep in mind that it's really the same equation. We're just replacing that symbol in the middle, okay, based on whether it's a growing situation or a decaying situation. So first, we're going to start by looking at examples that all have to do with growth. So let's talk about what the parts and the letters mean here. The A is our initial amount. The R is our growth rate, okay? They will give it to you as a percent, but we will need to use that growth rate as a decimal. So that's kind of an important note about the growth rate, okay? So 1, they're going to give you a percentage. 2, we need to convert that percentage to a decimal so that we can use it. And then finally, T represents time. How long has something been growing for? Now, keywords, if you were taking an assessment or your final exam at the end, these aren't going to all be broken down for you. It's not going to tell you this is a growth problem. So we do need to know the keywords that kind of help us understand that this is a growth problem. My keyword is increasing, okay, in a lot of these. So increases, increasing. You might also see earning or growing, okay, or multiplying. Let's say we were talking about the population of rabbits, right? So the population might double in size, okay, those kinds of situations. All right, so let's go ahead and jump right in with example number 1. I am going to ask you in your notes to always identify what is A equal, what is R equal, and what does T equal. Once we can identify these 3 values, then we can plug them into our equation and then simply use our graphing calculator. All right, so let's go ahead and read this. I am going to start with, let's see, the original value of an investment is $1,400. So 1,400. The value increases by 9%. So there it is as a percent. I need to change that to a decimal. So I would move it back 2 places and I would get 0.09. Okay, 0.09. So I'm going to write that here for my rate. And then my T, my time. They want to know, use the growth function to find the value of the investment after 25 years. So for time, I will put 25. And now I am ready to plug all of those values into my formula. So y equals A is 1,400 times 1 plus, because it's growth, my rate is 0.09, close the parentheses, and then the time is over 25 years. So now I have my equation. So now here's what I'm going to do to solve this problem. I'm going to pull up my graphing calculator and I am going to turn it on, and then I am simply going to type all of this exactly how I see it into my calculator. So type this into the calculator. And so I have 1,400 parenthesis 1 plus 0.09 close parenthesis caret 25. Make sure that it looks the same as the way I wrote it and then hit enter. Okay, and then I just write down my answer. So this is a value. So I'm going to do a $sign of $12,072.31. And that's my final answer. That is how I do an exponential growth problem. Let's do number 2 together. The cost of tuition at a college is $12,000. So my initial amount is $12,000. And it is increasing at a rate of 6%. So instead of 6%, I use 0.06. So R equals 0.06. Each year, use an exponential function to find the tuition cost after 4 years. So time is going to be 4 years. Now let's fill in our equation. So y equals 1 plus, okay, where my initial amount is 12,000, my rate is 0.06, and my time is 4. All right, and so now I'm going to go back to my calculator, and I'm going to clear this out, and I'm just going to type my new problem. 12,000 parenthesis. Now, if you want to do mental math, you could do the 1 plus 0.06 in your head. And so then just type 1.06, close parenthesis, caret 4 to the 4th power, and hit enter. And so my answer is $15,149.72. Great job. So what I'd like for you all to do now is to pause the video, and I want you to try numbers 3, 4, and 5 on your own. All right, raise your hand if you need to ask me any questions or if you get stuck somewhere. All right, I think that this is pretty easy though. You should be able to do it. So go ahead and pause the video now. All right, welcome back. I have gone ahead and completed numbers 3, 4, and 5 for you. I still color coded everything. The only thing that I did not show my thought process on is the translating these percents to the decimals. Okay, and so I thought that you should be pretty okay with that by now. 8% is 0.08. Okay. And then once I filled in my equation, I just went ahead to my graphing calculator and I filled in all the information, and then I was able to get my answer. Now notice that I did, if the answer was not money, then I identified what that answer represented. So in number 3, it was 440 student athletes. In number 5, it was talking about the population of a town. And so after 10 years, the population would be that number of people. Okay. Now if you're feeling like you got this, you know how to identify the information and plug it in, let's go ahead and do number 6 together. Okay, number 6 is the same idea, but it's got some information given to us in a slightly different way. Okay, so in 1985, there were 285 cell phone subscribers. Okay, the number of subscribers increased by 75%. So that's 0.75 per year after 1985. Find the number of subscribers in 2008. So they didn't give me the number of years that I need to put in for here. So here's what I need to do to find the number of years. I need to do 2008 subtract 1985. Okay. And when I do that, I get 23. So 23 years will have passed. So that's going to be my time. And that's the only thing that made this problem a little different. So from 1985 to 2008, how many years have passed? Okay. And now I can plug all of this in to my equation. Y equals 285 times 1 plus 0.75, and then raise that to the 23rd power. And so what I'm going to need to do is just go type this in my calculator. So y equals 285 parenthesis 1.75 close parenthesis caret 23 enter. And so this is going to be my answer. Cell phone subscribers boomed in that 23-year period of time. 45988.3. Okay. And so there's my decimals. Now, since we're talking about people, I'm going to go ahead and actually leave off the 0.3. Okay. Because this is subscribers. Alrighty. So that is our exponential growth. Let's go over and take a look at our exponential decay, which does work in the exact same way. All right, so A is still the initial amount, R is still the decay rate. Again, they're going to give it to me as a percent, and then I need to translate that to a decimal, and then the time in years. Now notice that the difference here is now I'm going to be using the minus sign, 1 minus the rate. Okay, and then my keywords are also slightly different. Most of the keywords for decay start with DE, DE. So decreasing, depreciating, declining, descending, if I'm maybe talking about a plane, right? And then downsizing. So they are all D words, which is good. That's helpful. Okay. All right, now let's go ahead and start with example number 7. So the population of a town is decreasing, so I know that I'm going to use the formula for decay at a rate of 1% per year. So my rate is going to be 0.01. Rate is 0.01. In 2000, there were 1,300 people. So my A is 1,300. Use an exponential function to find the population in 2008. So from 2000 to 2008, how many years had passed? And the answer is 8. So I will use T equals 8. And now let's fill in our formula. Y equals 1,300 parenthesis 1 minus the rate, 0.01, to the 8th power. Okay? And so you can type this in your calculator exactly how you see it, but I want to do some simplifying by hand first, okay? So we have y equals 1300 times, and if you did 1 minus 0.01, you're going to get 0.99 to the 8th power. And so I just want to remind you that this is still considered a times b to the x power, all right? And so my b value, b is less than 1, and that, like 0.99, is less than 1. And so that's also another way that I know that this is going to be decay, all right? All right, so I'm going to just erase this little note here, and then we're ready to go to our calculator and then type this in. So let's turn it on, clear that, and I'm going to type 1300 parenthesis 0.99, whoops, parenthesis 0.99, close parenthesis, caret to the 8th power, and hit enter. And then this will be my solution. Now we are talking about the population of a town, so I'm just going to put 1,199 people, and that's my solution. So this is exactly like our exponential growth, except that we need to use that minus sign in our formula. All right? So I think that you guys are ready to, at the very least, look at numbers 8, 9, and even 10 and 11. Okay, I want you to try these 4 problems. Even if all you're able to do is to identify the A, the R, and the T, I want you to do that and then check back in with me. All right, so pause your video while you do that. Back, I have gone through each of these 4 problems, and I've identified all the important information that I need to write the equation. So if you need to pause this for a minute and take a look at all of my original values, all of my rates, and all of my times, you can go ahead and do that. And I've also identified them in the word problem. Okay, and down here for number 11, my time is 8 years. Once you've had a minute to kind of evaluate what this information is, and then ask Miss Brown any questions that you haven't quite understood where I got my information from, then I want you to pause the video again, and I want you to write all of the equations for all 4 of these. So when you're ready, go ahead and pause the video again and start step 2, which is writing the equations. All right, welcome back again. I have gone ahead and written all of my equations, and then I took it a step further and I actually simplified what is 1 minus 0.12, 1 minus 0.10, 1 minus 0.02, and then I just simplified so that you could see the decay factor is 0.98, okay? It is really important to understand that when they say what is the decay factor, that it is the simplified value inside there. So decay factor. All right. Now I want you to go ahead, pause the video again, and use your calculator to get all of the final answers for each of these 4 problems. And welcome back again. I have used my graphing calculator to simplify all 4 of these, and it was simply a matter of typing in my simplified equation there in the middle, like the 18,000 times 0.88 to the 10th power. That's what I typed in my calculator, and it just spit out the final value for me. All of these 4 problems we're talking about money, so my final answers are all dollar signs. All right. And then here's number 11 so that you can see it. So if at this point you still have any questions about how to identify your initial values, plug them into the equation, or to simplify the equation, please raise your hand and ask me, and I will come over and assist you with that. For those of you who are ready to move on, I am going to do numbers 12 and 13 down here at the bottom with you. All right. Number 12, again, is straightforward with the minor exception of the fact that they don't give you the length of time in years. So why don't you pause the video real quick and see if you can identify the original amount, the rate, and the time based on the information that was given to you. And so your original amount should have been 28,000. Your rate, okay, whoops, I didn't want to cross that out. The rate should be, it's 2.5, so I need to move that decimal back 2 times. So I will use 0.025. And then my time in years, they didn't give it to me, but I know that I am starting in 2000 and I am ending in 2015. And so that should be equivalent to 15 years. Okay. All right. So I'm going to plug in 15 for my time. And now let's fill in this equation. Y equals 28,000 times, because it is decreasing, I will use 1 minus 0.025, and that will be raised to the 15th power. Okay, and now I do want to pause here and I want to ask you to tell me what is, for number 12, what is the decay factor? Okay, so go ahead and think about that for just a minute and then let me know what you come up with for your decay factor. And so what you should do is say 1 minus 0.025, and that should equal 0.975. That is the decay factor, and that's how I get it, okay? So let's go ahead now and type this all into our calculator. And so I'm going to type 28,000 parenthesis, my decay factor, which is 0.975, close parentheses, and raise that to the 15th power and hit enter. And so here is my final answer, 19,152. And this is a population, so I'm going to ignore the decimal. So people. Alrighty, great job. Now we are ready to look at number 13. An investment of $2,000 is losing interest at a rate of 6%. How much of the investment, how much is the investment worth after T years? Choose the best equation. So this is a really good example of an EOC problem, okay? An EOC problem where they're going to ask you to kind of set up the equation, but it doesn't look like when we initially set it up. You're going to look at this as though it has a decay factor here, okay? So an initial investment of $2,000. So what kind of value is that? And that is my A, that's my original value. So that should go right here in front of the parentheses. Okay, so which of these can I eliminate because the original amount is incorrect? And the answer is A and B are out. Okay, next it tells me that it is losing interest at a rate of 6%. So remember that means 0.06. So how do I figure out the decay factor? Losing tells me I have to subtract. So 1 minus 0.06 gives me 0.94, which is this one right here. So this represented decay. If you had done this incorrectly and added them, you would have gotten this equation, which is representing growth, okay? So we have our final answer of D. And then, of course, after t years, they just left the value of t for my exponent. They didn't even plug a number in there. Okay, so my answer is D. Great job. All right, there is an assignment posted for you on Google Classroom, and it is going to review everything that we've done today. You will need to be able to identify all the key features, all right, as well as the decay factor. So go ahead and practice. Miss Brown is here to help if you need anything. And until next time.